You guys had so much fun from those two graphs. Let's give you a slightly more realistic situation. Still virtual, still Canadian. So we got a hockey puck that's going to be moving here. So it's going to hit the boards over here. That's Canadian for the wall of the hockey rink. Okay. It's going to bounce back from there. And you have to do two things. One, find the impulse on the puck, and two, how much force was acting on that puck from the boards, which is the wall for American. I guess Canadian American fans would call it the boards as well. It's hockey. All righty. So here we go. There's a question there. Now, a couple things on the question when you click on that thing. So there's the mass, 107.9. So let me go to the annotate thing, and I'm going to go with the blue again. And I'm going to write that down to the side so I don't forget, because one of the things I have to do is the impulse, which is force times time, causes the mass to change velocity. It could be a change in mass, but in this case, the puck is not falling apart. So the mass, I'm going to write over here so I have that on my screen for later on, 0.1072 kilograms. All righty. Now, something else is the impact time. The impact time is 2.48 milliseconds. So the time of interaction with the wall, can be a lot of times involved here. So hold on. So this is the time that the wall, so it pushes on the wall pushes back in 2.48 milliseconds. So I got to go millis 3 places over. So the change in time on the boards is 0.00248 seconds. All righty. So the rest of the part of it is you have to find a change in velocity now of your puck. So I've got my mass, I've got my time, and I am ready to roll. I'm going to go hide my question so I can see what's going on here. And I'm not quite ready to enter my answers. Now, remember what time is what? It's going to have two things that are timing here. You'll see in a second. So you got to click on the puck, move your mouse over to the puck, click on the puck, and oh, there it is. It's not the real time. So the bottom time is going towards the boards, and this is coming back. So this is like some kind of a photo gate, could be a laser across there. And when the laser light gets blocked, it stops the time on that case. And when it hits the last little laser photo detector here, as it breaks the light, then it stops that time. I guess it's going off the back of the thing. So we have two sets of time. We have one set of time for going this way and one for going the other way. So I have to find my change in velocity. So remember, change in velocity is your final, oops, I'm not writing yet, is my final minus the initial. So sure, that's the mass, 0.1072 kilograms. But then times the change in velocity, I need a final and an initial. So my initial velocity is the distance between my photo gates here. So let's do this. Initial velocity, I'm going to do that up here. Is the change in x per change in t, not the time on the boards, the time crossing this distance. Okay, now that's in centimeters. So it starts off at 250, 270 centimeters, so 2.7 meters. And then the end time when it hits over here is at, so that's 50, 60. Oh, that's not quite, oh man. Is that really 270 or is it 69? I'm going to go with the 269, guys. Heck with this, 269 meters. Okay. This is a 50, 69. Oh, that's a tough one. I'm going to go with 69 on this one, guys. It's going to be easier math for me anyway. It'd be close enough, I think. So 69 centimeters or 0.69. That means the distance that that thing is covering is 2 meters in both cases, going and leaving. So for the initial velocity before it hits the boards, it's 2 meters. And the time to do that is, well, it's a 118.3 minus 46.8. Who's got a calculator? I do somewhere. That's a 1. And so that would be, what, a 7 there? So that would be a 71.5. I hope I didn't mess that sucker up. That's my crude math. So that's milliseconds. So I got to go over 3 places. So it's 0.0715. Guys, I am the king of screwing stuff up like that. So I'm going to double check because I don't want to do this twice. 0.3 minus 46.8. All right, at least I'm nailing that. So it's going to be 2 divided by 0.0715, 27.97. Okay, I'll call that 28.0. So the initial velocity is 28.0 meters per second. All right, now for the final velocity. College types don't put an F, they just keep it like that. Okay, if you're the college type. Still 2 meters going back. Excuse me. Now I need the time. So the time is the difference between there. So 559.8. I'm just going to use this 559.8. Well, see, I screwed it up already. 559.2 minus 248.4. Okay, 310. So that is a time, so that's 310 is the difference, milliseconds, 0.8. So I got to go 3 places over, so 0.3108, got way more sig figs here, seconds. Okay, there we go. So now I just go 2 divided by 0.3108. Bam, 6.44. All right. This is where people screw up, guys, because we have, remember, velocity is a vector. So if one of these is a positive, the other has to be a negative. It doesn't matter which way you pick. But I'm just going to call, for whatever reason, I'm going to call this the positive direction going towards the boards. That means that this is a negative velocity because it's the other direction. Okay, these are vector amounts. Make sure you have the direction on there. So since we're going in 180 degrees the opposite direction, I don't have to do the fancy trig stuff. All I have to do is put a negative on there. We'll do some fancy trig stuff later. Don't worry, that's still to come. Not right now, though. So to find the change in velocity, it's my final velocity first, negative 6.44 meters per second, minus a positive 28 meters per second. So minus is a plus and negative, right? All righty. So my impulse in my whole situation is, let me start this over. So I've got a 6.44, sure it's negative, plus a negative 28. So that's 34.44. And that's a negative. So in other words, here's what I have. 0.1072 kilograms times a negative 34.44, because that's the difference. See, it's going 28 one direction. Think of a number line, 28 on one side. I guess I do it on, there we go, that side over 28 on one side. Then it's going the other direction, a negative 6 points. That's here. So if this is 0, this is 0. It's going a negative 6.44. That's a bigger difference in velocity. So if this is the, if this was the 0, that's the 0. This is the 28. Negative 6 is over this way some more. It's a bigger difference. I'm adding my negatives together, which is negative 34.44. So that means my total impulse. So that difference times 0.1072. Drum roll, please. kilogram meters per second, or Newton times seconds, it's exactly the same unit. Since it's going to ask me for impulse, I'm just going to put a Newton times second. But a Newton times a second is, in fact, a kilogram times a meter per second. Oops, I didn't put my meter per second in here. My bad. So both work just fine. Okay, that's 1 out of 2 answers. The other answer was, what is the force now? Okay, so that was the impulse of the boards on the puck. Oh, whoo, I almost screwed up, guys. I don't think they're going to ask for the negative. They're going to ask for the absolute value probably. But since I called that positive, I should read the question, because if the question says make one direction a negative, I don't know if they're going to ask me to put a negative on there or not. There are two, the distance between the lines, blah, blah, blah. Find out how quickly the change in momentum. Oh, it's asking for the, well, the change in momentum is the same as the impulse. So the impulse was a negative 3.69 Newton seconds, and the change in momentum is a negative 3.69 kilogram meters per second. It's the same answer. Then find the force. I think they're going to give the positive value of that. So whatever. So now I know the impulse is the force times time. Let me change colors. So now that I know that the impulse, force times time, is a negative 3.69 Newton seconds, now I'm solving for the F, because I know what the time is. The time is the interaction in the wall, okay? This time was to just define the velocities. That's all that time was all about. Define the actual force. So we found the impulse, but you can't actually find the impact force, the impact of the force, unless you have the time. There's not a way. So anytime you want to measure the force of interaction on something, unless it's on a scale, if you're going to calculate it, we're going to find what's called the average force, because I don't have a graph showing me per time like you guys already did finding the area. I can't find the area to find the impulse. So I'm actually going to solve for the average force, which means divided by the time on both sides. And the time is the 0.00248 seconds. Okay, so it's going to be a sizable force, guys. Guess what those hockey players do? They smack those suckers. Well, actually, the board is smacking it. It's not the stick this time. All right, so it's 3.69 divided by 0.00248. Hope you appreciate this. So the answer is 1,500 newtons, okay? It's 1490 is what I'm getting over here. So 14, whoops, that's an extra zero. 1,490 newtons, because the seconds canceled out there. So there it is, guys, 1,490 newtons. There's the change in momentum. I am ready for my prize, okay? All right, enter the answers. Juju Schuster. Got a big keister. I don't know if he's got a big keister or not. I'm not that I'm staring at it or anything. So I'm going to put in the positive value of that, 3.69. And then the force would be 1490. I could get away with 1,500, I think, but this is how I roll. Well, there's the Newton second there. There's a Newton. Ready for my prize, guys. Calculations are correct. All righty. Well, guys, there it is. Oh, they did an original momentum and the final momentum, and they called original negative, whatever. I guess you're going on the number line, you're going to the left. So the Canadians called that a negative, it looks like. It's fine. It all works out the same. So there's the impulse, 3.7, and pretty much 1,500. There it is, guys. All righty. So that's the last activity, I think. I shouldn't say that because I might find more for you to do today. All right. Happy Tuesday.